Hi everyone, our topic today is on transducer. Transducer is the first component in any typical instrumentation system. After transducer, it followed by signal conditioner. Then we have analog digital converter, and then we have a display. So every component has their own function. So we're going to focus on transducer, where the function of the transducer is to convert the measured value into another useful value. This is basically a definition for a sensor. And normally sensor will convert a measured value, for example, any physical variable that we measured, temperature, pressure level, and etc. And the function of the sensor is to convert that temperature, pressure into another useful value, normally in terms of voltage. Then of course we have signal conditioner, where the function is to condition the signal from the sensor. It will prepare the signal such that it will be able to use in the next process. Then we have analog to digital converter, where normally used when the system require digital signal. So analog digital converter will function to change the analog signal into digital signal. Then of course we have display, and display can be in terms of analog display or digital display. So if it is digital, it's like computer software, monitor. The function is to process, to display, and to record the signal. Okay. Sensor is a transducer. Yes, this statement is correct. This is because we said that the definition of transducer is a device that converts measured variable into electrical signal. So that statement, that definition is suited for a sensor, because we do know that sensor is measuring physical variable, and the output of a sensor is voltage. Okay, but not all transducer are sensor. Okay, not all transducer are sensor. This is because transducer divided into two groups. Okay, the first one is sensor, where sensor is measuring physical parameter, and it will convert into electrical output. Then the second transducer type is actuator. So actuator is an mechanical device, an electromechanical device that receives an electrical input, then it will convert into physical output. So that is the definition for actuator. So both sensor and actuator are transducers, but not all transducer are sensor, not all transducer are actuator, because some of them are in sensors group, and some of them are in actuators group. So as a general definition, we define transducer as an electromechanical device that converts a mechanical change into an electrical change. Okay, so for example, here we have piezoelectric. Okay, piezoelectric can be both. Okay, when we apply force, it will give us voltage. So when in this mode, we design it as a sensor. But then we are also able to supply voltage to the piezoelectric material, and it will convert into displacement. So we use this mode to design as an actuator. So we do have piezoelectric motor, piezoelectric actuator. So it based on the concept where we apply voltage, and that we get some electrical movement. Alright, so piezoelectric will be able to be designed as sensor and also as an actuator. So let's try to understand what is transducer. So general definition for transducer is any device that convert the measured value into another useful value is known as a transducer. Okay, for example, here we have a few type of transducer, where for example spring. Spring is something that we apply force to the spring, then the output is given in terms of displacement, meaning different force will give you different displacement. So if you want to measure force, then the force is converted to displacement by the working principle of the spring. So spring is a transducer. The next one is thermocouple. Thermocouple is temperature sensor that convert temperature difference into voltage. Electromotive force is actually a voltage. Okay, so the measured variable is this temperature difference, and the useful value representing the temperature is the force. Then last one we have potentiometer. Potentiometer, the measured variable is the rotational displacement. How much rotation occur in the potentiometer, and that will be converted into a potential difference, which is also a voltage. Basically, we have two types of transducer, where it is called as an input transducer and output transducer. So this is the classification of transducer. So we have input transducer and output transducer. So input transducer is basically a sensor where it will convert a physical measured variable into electrical signal. So that is mostly a sensor. Sensor will convert physical variable, measured variable, temperature, pressure, and the output of the transducer is actually a voltage. Okay, voltage or current. So that is input transducer. Why the output transducer is basically inverse of that process. So for transducer, we apply electrical signal into the transducer, and the transducer will convert into mechanical movement. So basically output transducer is a actuator. So for example, motor here, okay, so we apply voltage to the motor, and the motor will give us rotation, will give us velocity. So the input is electrical signal, the output is the mechanical movement. So we can see in this diagram here. For example, we have tachometer. Tachometer is the sensor where it will measure the angular velocity, and the output from the tachometer is in term electrical signal. Then the electrical signal here will be fed into a controller. Okay, then the controller will calculate whatever signals that need to be sent into our actuator, which is motor here. So motor will require an electrical signal, okay, basically voltage, okay, 0 volt, the motor will rotate, and there is no rotation for 0 volt. Okay, 5 volt, the motor will rotate maximum rotation. So our motor here is actuator. Okay, so it will convert electrical signal into mechanical movement. So we have a sensor as an input transducer, fed a signal into the controller, then controller will give an output signal to actuator, which is we convert electrical signal into the mechanical movement. Then second type of classification of a transducer is in terms of analog and digital. There are analog transducer, meaning the output of the transducer in terms of analog, which is function of time. For example, voltmeter and oscilloscope. While we also have a digital transducer, where the output is in terms of digital output, meaning it only able to give output in terms of 0, 5 volt, high, low, on, off, 0, 1. So that kind of output is digital output. Okay, so example is the digital encoder. Okay, so this is analog voltmeter. So we have a display here. And this value is continuous in time. So the meter will move. Okay, we move from here to here. Then we get reading in function of time. So it is analog transducer. Okay, same figure. Then also for this oscilloscope, of course, in the oscilloscope, you will see some signal, something like this, right? Okay, so it is a function of time. So this is what we call as analog signal. All right. The third classification is based on passive and active. Okay, either the transducer is a passive transducer or it is an active transducer. So basically, passive transducer is defined when the system does not need any outside voltage supply in order to work, in order to operate, in order to function. Okay, for example, we have RTD here and thermocouple. Okay, both of these temperature sensor here, it will be able to measure temperature without needing any power supply. So we just put the thermocouple to the environment, then it will give a voltage representing the environment. If we use RTD, it is the same. We doesn't need to give a power supply to the RTD and thermocouple in order to measure a temperature. But for active transducer, in order to work, in order to function, in order to give output, an active transducer will need an outside voltage supply. You have to have a power supply in order for the active transducer to work. For example here, LVDT. Okay, in order to measure displacement, we need to give a voltage of current to the LVDT. Then only the LVDT will be able to measure displacement and provide output voltage representing the displacement. So without external power supply, the LVDT will not function. It cannot work. It cannot do the measurement. So that is the difference between passive and active transducer. Right, so this is the example of resistive temperature detector. Okay, it is actually a metal put into this shape here. Okay, this is the metal put into this shape here. So the working principle for RTD is basically based on the different material will have different resistance value when put into different temperature. So for example, if we have platinum here, so the resistance will change with the temperature. So based on that function, they design RTD, resistive temperature detector, then it will be able to measure temperature without any power supply. Alright, so basically this is a few type of principles used in designing transducer, basically for sensor here. So in this instrumentation, normally we talk about sensor. We focus on sensor, okay, not on the actuator. Okay, so later on we will discuss on how a sensor will measure any measured variable based on capacitive working principle. Okay, if the capacitance change, how the how the measured variable change, for example, pressure change, give any effect on the capacitive, and then how we can get the voltage output from there. Okay, based on inductive, resistive, piezoelectric, thermoelectric. Okay, this is for thermocouple. Photoelectric, piezoresistive, pyroelectric, and all these kind of principle of transducer will give us an output in terms of electrical signal. So we're going to focus on this type here up until photoelectric. Okay, next. As a summary, our topic today is on transducer, where we have discussed on a definition of transducer, where we said a general definition for transducer is to convert measured value into another useful value, and another one is a specific definition which is focused on sensor, which convert mechanical change into electrical change. Then we have discussed on the classification. Okay, so we said we classify transducer based on type, where we have input transducer and output transducer. Of course, you need to be able to provide example for all these kind of input transducer, output transducer. Then we classify based on active and passive, and we also classify transducer based on analog and digital type. Then we're going to discuss after this on the principle of transducer, where we will cover capacitive, inductive, resistive, piezoelectric, thermoelectric, and photoelectric. So that's all what we have covered in the introduction to transducer. Thank you.